Today's video topic is on the Boonton USB wideband peak power sensors. What is unique about the Boonton peak power sensor is its ability to display average and peak power simultaneously. Here we're looking at a pulse signal that has OFDM modulation. We can also use CCDF, complementary cumulative distribution function, as another way to display average power versus peak power. This is time in percentage versus our peak power in relationship to any given point in time. We also can display this in a split screen fashion. Here on the right hand side is my pulse display with the average and peak, and here's my CCDF values and my CCDF table of values. Another nice feature is the memory function, where we can actually display and store a trace against an active trace. By driving a limiter, which can be used to protect an amplifier or distributed antenna system type of products against overload, I'm going to drive the limiter by increasing the amplitude into the device. And what I'm seeing on the right hand side is my pulse power starting to rise while I'm looking at the CCDF display and seeing that I'm starting to get some separation down here. This is showing that we're actually causing potential bit error rate in our device or communication systems. What's important to realize when you're using peak power sensors, to do some work like this, you have to have fast rise time. In this case, we have a 3 nanosecond rise time and a large video bandwidth. In this case, we have 195 megahertz of video bandwidth. This is important when you're working with communication signals.